Hello dear students, in this session we will see one numerical of one-way post-tension concrete slab. In the previous lecture we have seen the uh, overall basic idea behind one-way slab, and we have seen there one numerical also, and today in this session we will continue with another numerical, and this was asked in the question paper. I think it is in 2018. Okay, so uh, the problem is almost same as compared to previous problem, only just for our uh, practice we are going to see this numerical once again. Okay, the deck of road bridge, the deck slab of road bridge of span 10 meter is a one way prestressed concrete slab. PSC means prestressed concrete slab with a parallel post tension cable. Force at transfer in each case is 400 Newton. The deck slab is in each case is 400 kilonewton. The deck slab supports a UDL of 25 kilonewton per mm square. Compressive and tensile stresses in concrete at any stage does not exceed 12 Newton per mm square uh, at and 0 Newton per mm square respectively. Determine only depth of slab assuming 20% prestressing loss. So first of all we see the given data. Span is given as 10 meter and force at transfer in each cable or in each case is 400 kilonewton, and it has given it is supported with the it has a UDL of 25 kilonewton per mm square, and compressive stress is 12 newton per mm square and tensile stress is 0, and loss of pre-stress is given as 20%. This pre-stress loss we have seen in the first unit, that is losses of prestressing. So it is the total loss of prestress given as 20%, and we have to determine only the depth of slab. So loads are given, then we will calculate the bending moment due to dead load and live load. So live load intensity is denoted by Q, and it is given as 25 kilonewton per meter square. Okay, and then moment due to live load is calculated as WL square by 8. Here W is Q for live load, and it is given as 25 into L is given as 10 divided by 8. Okay, so we will get the live load bending moment. Then for dead load bending moment we will calculate by using this concept. Assuming h is equals to thickness of slab, b is width of slab, and g is the dead load intensity. Q is live load intensity, G is dead load intensity, and this intensity is calculated as area into unit weight of concrete. Okay, just remember this point. Intensity due to dead load G is calculated as area into unit weight of concrete. So area is B into H and unit weight is gamma C. So we know the value of gamma C as 24. So B into H into 24. So and this will give us the value of W. Okay, W. Then we will calculate the dead load bending moment, WL square by 8. So W is B into H into 24, L is 10, and it is 10 raised to 3 is to convert this meter into mm. Sorry, 10 raised to 3 is to convert this kilonewton, 24 kilonewton moment into Newton. Okay, and WL square by 8, and 10 raised to 6 is to convert this B into H into meter. Okay, so we'll get the value in terms of B and H. It is mg is equals to 0.3 B into H Newton meter. Okay, You can keep units in kilonewton meter, okay. But for we will use this value here in the calculation of thickness of slab. That's why we'll have taken it as kilonewton meter, okay. You can convert there also, or you can convert here also, okay. Then thickness of slab, step 2 is thickness of slab. Now we have to do this range stress calculation, and then we'll go to the step for calculation of thickness of or depth of slab. Then allowable compressive stress in concrete FCT is given as 12 Newton per mm square, and allowable tensile stress in concrete is 0. Then range of stresses, FBR is the range of stresses, is equals to loss ratio into FCT, that is allowable compressive stress in concrete minus allowable tensile stress in concrete. Here allowable tensile stress in concrete is 0, and n, that loss ratio, is given as 20. So 100 minus 20, we have to convert it into decimal. So 100 minus 20% is 80%, and we'll get 0.8 value, and FCT is given as 12. So we get the value of FBR is equals to 9.6 Newton per mm square. Okay, it is clear. Then we go for minimum section modulus required. Minimum section modulus required from this, and from this point we'll get the height of slab, okay. Sorry, minimum section modulus required, BH square divided by 6 is equals to MQ plus 1 minus loss ratio into mg divided by FBR. Now here we will calculate this height or thickness of slab per meter width, okay. So we will assume B is equals to 1 meter, and then we'll put the value of B as 1000 mm, that is 1 meter, and we'll solve for this H value, okay. So putting all this value, and we'll get the value of before that we'll get one equation in terms of just this this equation can be solved in the calculator using equation mode, okay, and then we'll get the value of H as 470 mm. We'll round up to the 470 mm, and this will complete our one numerical for design of one way pre-tension slab, okay. If you have any doubts regarding this, then you can directly contact me, and just keep practicing. uh, in the exam there is one question, definitely one question on one way slab or two way slab. So in the next lecture we will see the design of two way slab. Design of one way slab is much more limited, or we can say easy, and design of two way slab is also easy, but it is quite lengthy as it is two way slab. So we have to design in x direction and y direction, that's why, okay. Thank you.